Welcome to another video and episode on my Raspberry Pi 2 running Ubuntu Linux in combination with ROS operating system programmed in C++, connected to a hidden network cable for VNC, HDMI cable for booting, but the resolution is too low to be of any use, and a serial cable for connection to Minicom serial terminal. Connected also with a band cable to this breadboard with some electronics and a fischertechnik LED, phototransistor and motor with propeller. Last time I finally managed to get things working, in the sense that I can now make sure that everything is being sent and addressed. How did I accomplish that? Well, using the wiringPi library, and after I got that working, after quite a few attempts, last time I managed to incorporate them in a ROS program, but I didn't try yet to actually run it. So that is the focus for this time. After I reseat the wires, because with loose wires you can't see anything. So one thing, if I manage to get things done on the Mac, which I did last time, I will do so. But for now, let's try to get things working, and for VNC I need a laptop, so let's see how that works out. So first of all, introduction for in fact that you don't know anything, two VNC desktops. Desktop 3 is on my Android tablet, desktop 4 is on a Mac. Then one window for running the node, the ROS node FT control, one for FT motor, this one for running the test application to run everything, and the point is that that is in a slightly different video series, so you might want to look that back. Anyway, if I run this, then you will see that everything works nicely by now. Then ignore this please. This is, by the way, the Minicom the Minicom connection that I showed you on the Raspberry Pi. This is the source code of the control node, and this is the source code of the motor node. Last time I added this, compiled, and it ran. Now I added this code, because that is the code in here to make things run, and in this case the green LED, this tiny one. And of course I need to do some more stuff to get things running. starting ROS score is one of them. Otherwise it won't work at all. And now I can actually run things, but then I will run the software without digital write. So let's first see if things run anyway. And here I have to do catkin make for checking on this stuff. But first, control, yeah, motor, yes. Alright, so this works. Now the time is to see if this will compile and run. Here I have defined the output, not here. Will this make out? Will this be working, or should I put this here as well? I'm going to find out. Catkin make. What will happen? If it says I don't know digital write in the motor node, then I know I have to adapt things. Time will tell. Yep. What did it not do? Digital write. See, that is the whole point. It doesn't know digital write. So and I have put digital write here. Now this is typical. And this is in motor CPP. And this inclusion is the same one as this one, not the same as this one. So I am going to include this line in here. No, not here. Paste. Right. Okay. Next attempt. This should fix it. Well, this should fix this error. Which I hope it will. No, it doesn't. It says undefined reference. Oh, then what I'm going to do is commenting out, because this is interesting. If this doesn't work yet, without even this one, that means that I have to adjust my settings. So here goes. This is unexpected. Linking. Okay. So I don't have to really adjust my settings. But if I look, oh wait, wiringPi setup, here also wiringPi setup, that is all alright. So then why does it not accept this? Should I take wiringPi setup here as well? Basically, I shouldn't. This is interesting. Why does it here not accept this one? I could of course check it anyway, that it has to accept it in FT motor. Let's check that. So, alright, now I will go here, open a new tab and CD catkin, ROS CD. Oh no, I first have to source of course. Then ROS CD to Raspberry Pi stuff. Then VI glazed. And now I have to go to the very last couple of lines right here. And I have to widen the window. Right, this is better reading. Yes, and that is the whole point. What I did here, I have to do here as well. So, I have to add wiringPi, wiringPi dev p thread m crypt and real time. Oh, and add a space. Exactly this. What is happening now? Oh wait, I'm not looking at the end. That is the whole point. So, yeah, saved another time. Now, I can, hopefully, change this one. Alright, now let's see what happens. And I can't say anything yet. Oh wait, it is of course now including all the libraries for the other one, so it did take a bit longer time. It did take some more time. See, this works. This works. Now, let's run things again. That is 1. And this is 2. What happens? Basically, well, nothing. Because of what? If I look back here, it is LED 12, the green LED. Can I run this at the same time? Let's see. Yeah, I can. And this will quit soon. Yep. Alright. So it is not the wiring that is a problem. So why do I not get to see this happen? quit and quit. So this is a strange thing. I need to actually put a ROS info in here. And ROS info is for ROS the same thing as a print statement. So here, okay. And here I say green, no, wait. Green LED. That is what I should see. But will I? Okay, cat can make. So, compiling done. So let's start the control again, start the motor again. See, but it doesn't do a thing. So what I most likely have to do is put pin mode in there. Alright, let's check about that. So wiringPi setup and pin mode 1. Copy, go here. Where should I do this? Somewhere in main. So I will say insert, paste. Here's our node handle. This is all set before the while. So this is exactly, well, not exactly the same, but more or less the same. Pin mode, and then it should work. Unless there's something happening again. But let's see. Because if so, I will have to remove all this and put it in here. Since I want to do all callbacks to the various elements from here, not from the control. Okay, everything is done. Go for this one. Go for this one. Yeah, look at this. It is working actually. The only thing being that it is not flashing the way I like to see, but that's just a detail. So what I now have to do, copying all this right here. Paste. Alright, that's one thing. So basically, well, yeah, what do I do with this? Well, remove, or more appropriate, no, more appropriate is comment out. Now from here, let's add the delay here, and that should be a blinking thing. Right, let's make. Should be going rather quickly. should be linking both. Yeah, I changed both, so that's correct. Control and run. Yeah, now it's blinking. Alright. But what I would rather do is, since this is called motor control, where is the motor? The motor is set to which one actually? Let's go take a look here. Motor is that's LED. Then we have the motor, which is 6. So I have to do 6 here and 6 here, and of course then motor. Alright, once again, cut, Catkin make, and now instead of, yeah, this is a bit odd because it's still running, which I don't like. Let's run, let's quit this, and let's quit. So why is this not stopping? Okay, now it is. So run, run. Whoa, I took the wrong one. Okay, 4 it will have to be. It has to be 4, not 6. Oops. So yeah, I'm only building the motor, so stopping the control is actually not necessary, not strictly necessary. And there we should be. Yes, thank you. Control motor. Yeah. It is jumping around, so I should give it time. And time I will give, let's say 2 seconds. That will be good. And the program still runs, which I don't like. Finished building. And why is this happening? Why can't the program just stop? Alright, it finally stopped, so I can now run the compiled program with 2 seconds delay for the motor. So pay attention to this part of the screen. and this is better. What you can also see is a probe, which I attach now, which means oscilloscope view, and for that I will skip to the Mac in a bit. So let's run this one. Which doesn't do one single piece. Which is not, by the way, completely true. You can see it move a bit, but I need to make it longer. How long should it be? Well, I have put the motor to 5 seconds actually. So I have to change it to 5 seconds. No, this should be 0. So 5 seconds. And then compile again. And then 5 seconds should be sufficient to make it run. And then I have my motor node. And then I can create an LED node and a phototransistor node if it is alright. And that is still a big question. Okay, let me now start the motor node from the Mac, because I have prepared the Mac to do that. Starting it. And unfortunately it doesn't do a bit. And it has trouble stopping there as well. Okay, let me stop the control. This is unfortunate. So now the same node has a problem when I execute the VNC for the on the Mac and right on here, which I do not like. Why? Why has it problems? It is still making movements. Anyway, let me show what happens on the Mac, because that's interesting to watch as well. Alright, so on the Mac now, as you can see, by now on the other laptop it shows that the program has stopped. Not so much here, it's still running, but another interesting thing is this one. So pulses modulation on the oscilloscope, and it has a considerable delay, if it is delayed at all. I need it to run. Now it does, but it has about a second delay. So let me now, no, that's the wrong direction, this one. And I'm afraid again there's a stalling in the signal on the oscilloscope or in the camera. So, oops, that was not the intention. Yes, there we are. However, there's a massive delay here. See, there it comes very quickly and then, yeah, this is a lot better. And yeah, the effects are probably due to the fact that this is an old MacBook. Anyway, is this? Well, this isn't doing anything, but the point is now that here it shows or should show the pulse modulation. There you have it, but it is rather weak. And if I could show you the motor, it is still jolting, little movements. Not on the 5 not the 5 seconds anyway. So why is this not working? Okay, let's quit this one, which ends the process. Now let me see whatever happens if I do it. No, not that one. Okay, there's a severe delay in commands on the Raspberry Pi. I think I am asking too much of it. But anyway, you can see that right here the pulse modulation is there. I give it a certain speed, but there may be a chance that the voltage is too low, although I set it to 5 volts, which is certainly coming from Raspberry Pi. Anyway, would have been a nice idea to show it here, but alright. So the pulse modulation is not quite visible. By now here everything is, well, it's not really functioning as I had hoped. The 5 seconds, I don't know why. I don't know why the motor node is having problems stopping or being stopped. Apart from that, with the code now entirely here and here out of it, so I can scratch this. This includes as well. I'm on the right track. How about LED or whatever remains to be seen, because that is what it was. That is the point where it went wrong with the Python version. So how will it go here? I don't know yet. I will have to wait and see. I'm glad that the hardware does work, but for the rest, who knows? And now it's really more than time to wrap up. Yeah, I can outside ROS run it again, and then you see that everything does work. So no hardware problem, that's for sure. And that is it for now. So some improvements of the programs. The question is only what can I do to improve it. I'm not sure yet. Remains to be seen. Oscilloscope, well, whatever you've seen it. So I hope I can get it to mainly this to work next time for 5 seconds on and off. Anyway, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, most appreciated. You can also follow me via Twitter and Instagram. Please show your appreciation by making a donation via either PayPal or Wired. And you can also become a patron in support, and you may have your name mentioned as a supporter, depending on the pledge you make. All information is under this video, including the URL of my website for much more information. For now, to be continued. Have a nice day and bye bye.